Okay, here are solutions for a perfect problem for Math 65. In this problem, we're asked to do polynomial long division and then check your answer, is the short of it. So when you're doing polynomial long division, you kind of take your denominator, x squared plus 3x minus 4, write that out on the outside, and then make a long division sign, and write our numerator. So in this case, 2x to the 5th plus 5x to the 4th minus 8x cubed plus 11x squared minus 18x plus 8. And so really the easiest way to think about this is the process we're going to use is a lot like regular long division that you may have learned at some point in your math career. And with regular long division, you kind of work from the left to the right, and you're trying to get rid of the digits on the left, working your way right. Same idea here, except instead of getting digits, we're getting rid of terms. I want to get rid of this 2x to the 5th right here. And the way I'm going to get rid of this 2x to the 5th is I'm going to write something up top here. It'll end up being 2x cubed in this case, but I'll explain why that is. You write something up top here so that you'll be able to cancel out this column. The idea is in every single step we want to get rid of one of our columns, and we're going to move from left to right. So first I want to get rid of this 2x to the 5th column. Why is 2x cubed the key to getting rid of 2x to the 5th? Because, as you may remember from long division, whatever you write on top, you then take and multiply by whatever you have out here. So if I do 2x cubed times all of this stuff, what I would get is 2x to the 5th power plus 6x to the 4th power minus 8x to the 3rd power. Now why that is good is the next step in our long division algorithm is to subtract. Always going to be subtracting. 2x to the 5th minus 2x to the 5th, that cancels out. I get nothing here. I managed to get rid of this column like I wanted to. 5x to the 4th minus 6x to the 4th sounds like negative 1x to the 4th. Negative 8x cubed minus negative 8x cubed is the same as negative 8x cubed plus 8x cubed, which is just 0x cubed, which you could just leave blank. I'm going to put in a 0x cubed kind of just as a placeholder. You don't have to write that there. And then I got this 11x squared that I'll bring down. If you can get to there, you can do this entire problem, because really all we're going to do now is repeat. Do that same process again, except instead of getting rid of this column, I'm now getting rid of this column. I want to get rid of negative x to the 4th. I have to put something up top, negative x squared in this case, so that when I take that something and multiply it by this polynomial, let's multiply that negative x squared by this polynomial, we get negative x to the 4th minus 3x cubed plus 4x squared. When I do that and then subtract, I want to make sure I get rid of this column, and sure enough I did. Negative x to the 4th minus negative x to the 4th is the same as negative x to the 4th plus x to the 4th, which is just 0. 0x cubed minus negative 3x cubed is the same as 0x cubed plus 3x cubed, which is 3x cubed. 11x squared minus 4x squared is 7x squared. And then I'll bring back down my next term, negative 18x. Repeat again. Want to get rid of this 3x cubed. To get rid of this 3x cubed, I got to put a 3x up top. Why 3x? Because 3x times x squared is 3x cubed. 3x times 3x is 9x squared. 3x times negative 4 is negative 12x. And I subtract. 3x cubed minus 3x cubed, those cancel out. I managed to get rid of another column. That's good. 7x squared minus 9x squared is negative 2x squared. Negative 18x minus negative 12x is the same as negative 18x plus 12x, which is negative 6x. And then I got this plus 8 out here. One more time, I want to get rid of this negative 2x squared. To do so, I'll put a negative 2 up top, because negative 2 times x squared gives me negative 2x squared. Negative 2 times 3x gives me negative 6x. Negative 2 times negative 4 gives me positive 8. I then subtract. Negative 2x squared minus negative 2x squared is the same as negative 2x squared plus 2x squared. I get 0. Negative 6x minus negative 6x is 0. 8 minus 8 is 0. I get 0, which is a good thing because it told me up here the answer should have 0 remainder. So my remainder down here, I got a 0. That's a good thing. What that's telling me is this mess up top appears to be my answer. However, we're not done, because I want you to check your answer by multiplying this thing times this thing and making sure you get back to this thing. Division has this nice property that you can check your answers to division by doing multiplication. So what I'm now going to do, kind of step 2 over here, is I'm going to multiply two polynomials together. I want to multiply together, well, I have room, I think I'll have room, 2x cubed minus x squared plus 3x minus 2, this thing, my answer, and I want to multiply that by x squared plus 3x minus 4, and I hope when I do everything carefully, I'll get this mess down here as my answer. If I do, I'll have a nice check here, and I'll be feeling pretty good, and I'll call that the end of this problem. So let's see what's going on. Multiplying polynomials, I do it using this box method. You can do it using any method you want. The idea is fill in all the boxes. X squared times 2x cubed is 2x to the, I'm going to switch colors so things don't run together as much. It's 2x to the 5th power. X squared times negative x squared is negative x to the 4th power. X squared times 3x is 3x to the 3rd power. Negative 2 times x squared is negative 2x squared. 2x cubed times 3x is 6x to the 4th power. 3x times negative x squared is negative 3x to the 3rd power. 3x, 9x squared. 3x negative 2, negative 6x. One more row. Negative 4 times 2x cubed is negative 8x cubed. Negative 4 times negative x squared is positive. Negative times a negative is a positive. 4x squared. Negative 4 times positive 3x is negative 12x. And negative 4 times negative 2 is positive 8. If I now combine like terms, I got 2x to the 5th. As far as my x to the 4ths go, I got 6 of them here and negative 1 of them here. So I have 5 of those x to the 4ths. For my x cubes, looks like I got negative 8 of them here, negative 3 of them here, and positive 3 of them here. Well, negative 3 plus 3 is 0. Minus 8 more gives me negative 8x cubed. What about my x squared terms? I got 4, I got 9, I got negative 2. 4 and 9 is 13. Minus 2 is 11. My x's, I got negative 12x minus 6 more x. I got negative 18x. And then I finally have my plus 8 here. The product of those two polynomials appears to be this thing. And I really hope that that's what I see when I look up here. 2x to the 5th, 5x to the 4th, negative 8x cubed, 11x squared, negative 8x plus 8. Awesome. I'm feeling pretty good about my answer up here, which I'm going to throw a box around for no apparent reason, and then end this video there. So there's how you can do some polynomial long division and how you can check your answer.